This video is created and shared as part of a partnership with Allianz Direct.
Hey! In the previous video, we've defined what service mesh is and why you might need it. If you've missed it, go and watch it first, because in this video, we will compare some of the most popular and production-ready service mesh technologies. We will also mention some of the emerging and promising service meshes, though as they are not yet as mature and tested as the other ones, we won't dare to recommend them just yet. Keep in mind that this video is valid at the beginning of 2022. Technology evolves and changes really fast, so things might be very different at the time when you watch this video. Let's start by defining criteria that service mesh must fulfill. This will allow us to build a shortlist of the service meshes that we want to compare. Criterion number 1, open source. We are going to focus on the open source offerings that are developed and supported in open by multiple companies and many individual contributors. This also rules out any cloud vendor specific services like AWS AppMesh. Criterion number 2, covers 3 pillars of service mesh. There is no dictionary definition of what a service mesh is, but we will only look at the ones that provide at least some features around each of the security, observability, and traffic management areas. Criterion number 3, version 1.0 or above. If you need to choose a tool for your stack, it's a good idea to stick with something that exists since a couple of years and was validated and tried by other people. There are bigger chances that many critical bugs are already fixed, and many of the features you might need are already implemented either directly in the tool or by the community. Criterion number 4, support multi-cluster. You rarely have just one Kubernetes cluster. In case of production clusters, you might have multi-region clusters or clusters for different purposes, and it helps to have a unified layer of observability, security, and traffic management for failover debugging and end-to-end encryption. Bonus point, follows or attempts to follow service mesh interface. Let's stop for a second to talk about service mesh interface or SMI. SMI attempts to define a specification for common traffic management features of a service mesh. The idea is that instead of every service mesh providing its own custom resource for, let's say, traffic splitting, they would instead follow the SMI specification. The potential benefit is that you can swap service mesh implementations without necessarily changing your whole stack. Naturally, it will never be as easy, but the concept is nice. SMI is quite fresh, but goes in the same direction as other specifications in Kubernetes world, like Open Container Initiative, Container Storage Interface, Container Network Interface, and so on. We always support proper standards and specifications, and we give preference to the service meshes that follow the lead in embracing and supporting SMI. With the criteria defined, let's look at the short list of the service mesh technologies that we've prepared in no particular order. Linkerd, Istio, Consul Connect, and Kuma. We've also tested Open Service Mesh, but it quickly became obvious that it's not quite ready for prime time, which is fair enough given that its version 1.0 release didn't yet happen. This is how we tested each service mesh. We've deployed a new clean AWS EKS cluster with AWS ALB controller taking care of the ingress. We then deployed a robot shop, an open source application that consists of 11 microservices, including a couple of databases. We intentionally avoided any of the service mesh provided demo applications, as we wanted to see how the mesh will behave in a setup that was not intentionally built to showcase this mesh. Afterwards, we installed the service mesh and tried to connect aforementioned microservices to the data plane. Once this is done, we tested various features of the mesh, including MTLS, traffic control, authorization policies, and so on. Out of curiosity, we tried using service mesh with AWS EKS Fargate, serverless offering for EKS, but none of the meshes we tested was able to run proxies in Fargate pods due to security boundary enforced by Fargate. We will look at each mesh from 5 different angles: installation and configuration, data plane implementation, MTLS and identity management, traffic control, and observability. We will also take a brief look at Cilium as a high-performant alternative to a fully featured service meshes. In the end, we will draw some conclusions about which service mesh is the best and the worst one. We start by comparing the installation experience. In most of the cases, mkdev recommendation is to use Helm for packaging and deploying Kubernetes applications, especially cluster-level components. Almost every service mesh we tested, except Consul, provides a special CLI tool to install the mesh. In case of Linkerd, the CLI tool is the recommended installation way. We found the CLI to be easy to use, and it provides a set of useful features like verifying that your cluster is compatible with Linkerd. Installer itself merely generates Kubernetes manifests that can be then applied to the cluster. We would recommend to store those YAMLs in the source control. You can also use a Linkerd Helm chart, even though in that case you need to generate identity certificates yourself. If you choose to use the CLI, you won't be able to easily switch to Helm later on. In case of Istio, it is surprisingly CLI focused. Helm chart is currently marked as alpha, while operator mode is not recommended for new installations. The only choice you have is to use the Istio CTL, which, like Linkerd CLI, can generate manifests instead of instantly installing the mesh. On the good side, Istio provides installation profiles that allow you to select which exec features you expect from Istio. There is, for example, a minimal profile that gives you just the basic components of Istio. Among all the meshes, we found Kuma to provide the biggest number of installation options, starting from an excellent Helm chart and going all the way to even support CloudFormation-based installation on top of AWS ECS, so that you can run Kuma control plane outside of the Kubernetes. Finally, Consul installation is entirely focused on an excellent official Helm chart. The only problem is that, in addition to the Consul Connect, you have to install Consul itself, unless, of course, you already have a Consul cluster running inside of Kubernetes. Consul is not a Kubernetes-specific technology, it's a separate, almost decade-old service discovery tool that was built to work on any infrastructure. It has its own key value storage and its own way to configure things. To conclude, each service mesh except Istio has a proper Helm support and can be installed and updated as any other Kubernetes application. The quality of the charts varies from mesh to mesh, with Linkerd and Consul leading the way in terms of amount of options you can configure and the quality of the documentation around those charts. When we install the mesh, we install the control plane that is in charge of everything that happens in the mesh. The second part of the mesh is the data plane, and there are some differences in how data plane is implemented in each mesh. Each mesh we looked at uses a sidecar proxy pattern. It means that all of your pods in the mesh will need to run an extra container that takes over the network connections to your application. Every mesh we tested, except Linkerd, uses Envoy as a proxy. Envoy itself is a separate open source project that you can run without any service mesh. Because Envoy was built to be a cloud-native proxy, most of the service meshes rely on it to build a data plane. It also means that most of the service meshes share the same set of features that Envoy provides, and they also depend on the Envoy project development cycle. The only exception from this is Linkerd, which has its own sidecar proxy that, according to benchmarks, is many times faster than Envoy. Linkerd proxy is intentionally small and focused, and it has much less features than Envoy. Consul Connect also uses Envoy as a sidecar proxy, but it also runs a daemon set with Consul agent. What it means is that in addition to an extra container next to each of your pods, Consul adds an extra pod on each of your cluster nodes. Once again, Consul is not a Kubernetes-specific tool. It's a general-purpose agent-based service discovery and service mesh technology that happens to support Kubernetes. Each service mesh gives you 4 options to include a sidecar proxy and thus mesh your service into the mesh. Automatically inject the proxy for every pod in the cluster. We would not recommend this approach for existing clusters due to potential impact. Automatically inject the proxy for every pod in a certain namespace or workload, or manually inject the proxy into the workloads you need. For each mesh, you have to recreate your pods for the proxy to be injected. Each service mesh we tested supports MTLS, meaning it gives your pods certificate-based identity and it encrypts all the traffic between meshed services in the cluster. Each mesh allows you to use external PKI and provide your own certificates, and each mesh has multiple sources of identities for your pods. The default one in most cases is to use Kubernetes service accounts, but if you mesh services outside of the Kubernetes, then for example Istio allows you to use another source of identity. Worth mentioning that Linkerd is working only with Kubernetes, while Istio, Kuma and Consul Connect can be used on any infrastructure. Each service mesh also allows you to configure authorization policies tied to the service identity. You can say that this service only accepts connections from such other service. The challenge with MTLS is that, unless in a greenfield environment, you are rarely able to make every single pod part of the mesh at once. But once you have a pod with MTLS enabled, this pod would want to validate and encrypt all the incoming traffic. And while MTLS works transparently between already meshed pods, it gets a bit tricky with the external connections that are not part of the mesh. In simple words, you cannot have mutual TLS if one side of connection does not have any certificates of its own. There are two problems with this. First, your Kubernetes cluster performs health checks against your pods, and your Kubernetes node is not part of the mesh. If you want to enforce MTLS, you need to make sure that the mesh can handle this case. And second, your ingress controller to get external traffic to the cluster might not run inside your cluster itself. For example, most of the public cloud ingress controllers simply provision a managed load balancer outside of the cluster. This load balancer cannot be part of the mesh, thus it won't be able to participate in MTLS. Every mesh solves this problem differently. Kuma does not have MTLS enabled by default at all, but once you enable it, none of the non-meshed components will be able to talk to the meshed ones. That, unless you enable permissive mode in which out-of-mesh services will talk to the meshed ones over a plain stack connection. Permissive mode cannot be overridden per service. Linkerd takes a simple approach. It does not enforce MTLS at all, so any connection from the outside will not be encrypted with Linkerd. This is similar to the permissive mode of Kuma. You can enforce MTLS by using Linkerd authorization policies, and in this case, any non-meshed connection will break, including native Kubernetes probes, unless you whitelist based on the source IP address. Istio allows you to mark certain connections to be in permissive mode so that non-TLS connections are allowed. This is similar to Kuma's permissive mode, but Istio goes further and lets you set permissive mode only for a particular service. Still, Istio is supposed to be used with its own ingress gateway. This ingress gateway sits between your meshed services and your external load balancer, and you can benefit from Istio features on the edge of your cluster. Consul Connect uses the same approach with the difference that it does not have any way to allow non-meshed connections. Instead, you are forced to use Consul Ingress Gateway to get non-meshed traffic to your pods. This is where lays one of the biggest differences between meshes. Kuma and Linkerd let you use your existing method to get traffic to the cluster, while Istio and Consul take over this part and force you to rethink how you handle ingress connections. The trade-off Kuma and Linkerd had to make is to avoid enforcing MTLS for complete traffic and reserve it only for internal meshed communication. When comparing the traffic control capabilities of the mesh, you have to first decide which exact traffic control features you need. The only feature that is present in each of the meshes is traffic splitting, and traffic splitting is arguably the one that will be used most by a majority of the service mesh users. Linkerd has the least amount of traffic control features. Besides traffic splitting, it also allows you to configure retries and timeouts for your services. Linkerd traffic splitting is implemented via SMI traffic split API instead of providing their own custom resource types. This is different from Consul, Kuma and Istio. Each of those has their own custom resources for traffic control, and each of those provide the most flexibility around how to move traffic inside the mesh. They all, for example, allow to route traffic based on the value of an HTTP header, something that Linkerd is not capable of doing right now. If you have a big requirement to configure advanced routing inside the mesh that goes beyond simple canary deployments, then Consul, Kuma, and Istio are your best options. Keep in mind that each of those three can be quite complex to configure. You need to create multiple objects of different types, and despite generally great documentation of each of those three meshes, getting traffic control right is quite a complex task. We found that among those three meshes, Kuma custom resources are the easiest to comprehend and to configure. You should also remember that the more complex your traffic control configuration is, the bigger impact it has on latency. If latency is critical, then your best bet right now is Linkerd. Even though it lacks many features, it's much more performant and lightweight than standard envoy-based service meshes. Another thing to consider is that over time, each service mesh will get more features around traffic control. So for example, if you do not have a hard requirement for header-based routing or circuit breaking right now, you can safely pick Linkerd, knowing that in the future, most likely, these features will get there too. A bit of a mind-bending detail of traffic control in a service mesh is that it happens on client side and not on the server side. This means that traffic splitting will work only if the client is also part of the mesh. Keep this in mind when integrating service mesh with existing applications, as the result might surprise you. To benefit from traffic splitting, for example, your load balancer has to be part of the mesh. That's one of the reasons Consul and Istio have ingress gateways. In simple terms, observability consists of two parts. Collection of as much data about your system as possible, which includes metrics, logs, and tracing, and tooling to easily explore this data to be able to find what's going on in your system. When it comes to data collection, all service meshes are more or less identical. Each exposes a lot of metrics about everything that is happening between your services, each integrates with Prometheus and Grafana, and each works well with tracing systems like Zipkin and Jaeger. Every mesh can be installed with built-in monitoring stack, and every mesh recommends in the documentation to roll out your own monitoring stack for production deployments. This means that even though you can use Prometheus or Grafana bundled with the mesh, you really should rather integrate your existing Prometheus and Grafana instead. But providing the data is only one part of the observability. The second part is the tooling to explore this data. As already mentioned, you can use Grafana and tracing tools with each service mesh. What's more interesting is the tools mesh provides on top of that. Istio has Kiali, which is a fantastic web UI to visually explore almost everything that is happening in your mesh, all the connections between meshed and non-meshed components with metrics and dashboards. The graph view of Kiali is especially great, and it has many configuration options and can be tweaked to show every possible detail of existing connections. Linkerd, the web dashboard, is also pretty nice, though it's not as comprehensive as Kiali. It also has a graph overview, but it's way simpler than the one in Kiali. On the other side, Linkerd provides a unique tab feature that lets you hook into the live traffic of every mesh service and explore every connection in details. This kind of debugging tool is essential for proper observability. Both Consul and Kuma also come with their own dashboards. Both very good looking, though not as useful in practice as Kiali and Linkerd. Consul dashboard can pull metrics directly from Prometheus, but does not have a graph overview of all connections. It's also confusing that it shows you that every service is connected to every other service instead of visualizing only existing connections between them. On the positive side, there are direct links to documentation about particular feature of Consul. Plus, let's not forget that this interface is not only for the service mesh, it serves as a general Consul dashboard. Kuma's dashboard surprised us by a nice data plane installation wizard and generally nice design, but in the end it appeared to be a simple read-only table overview of your mesh. But on top of this dashboard, Kuma gives you excellent Grafana dashboards with a custom data source and a graph overview of each service right inside Grafana. Before we wrap up, we should mention Cilium. Cilium is not a service mesh in a traditional sense of it. Instead, Cilium is a container network plugin that uses eBPF instead of IP tables. We won't go into details about what eBPF is, but in short, it allows to run software directly in the Linux kernel, which results in a greater flexibility and performance gains. tell us if you want to see a separate video on eBPF and Cilium. Installing Cilium requires you to get rid of existing CNI plugin. So for example, if you have an EKS cluster with AWS VPC CNI, you need to remove it first and then install Cilium and restart all pods. As you can imagine, such an operation can be quite dangerous for a production cluster, so we would only recommend using Cilium in new clusters. Once it's installed, you can configure network policies with Cilium. Those network policies are quite simple when you compare them with the proper service mesh. You can only say that pods with these labels can or cannot access pods with this other label. There is no identity-based authorization. But because of eBPF, Cilium is capable of doing something that none of the service meshes can. It is able to understand what kind of traffic is going through it and enforce policy based on this traffic. So for example, you can create a policy specific to Kafka or Cassandra traffic, and these policies will work in the kernel via Cilium's eBPF software, and it will be much faster than anything you might implement with Istio or Linkerd or other mesh. eBPF also allows you to explore live traffic between every container down to the TCP packet level. There is a separate web UI called Hubble, as well as the CLI tooling that can hook into the traffic and let you explore it in detail, a bit similar to Linkerd tab feature, but on a much lower level. In general, Cilium in its standard form is more of a very advanced and high-performant networking tool with an ability to configure traffic-specific firewall rules and low-level network observability utilities. But there is also now a Cilium service mesh that combines Cilium's network plugin with Envoy proxy per cluster node. As of now, this is still in beta, but in Google Cloud Platform, for example, you can already use eBPF with Cilium and Istio altogether. Cilium's approach with eBPF and network policies, even without the service mesh, gives you many of the features you might need from the mesh, at least around security via transparent IPsec encryption, observability, metrics, and pod-to-pod firewall. You can combine Cilium with existing service meshes, for example, use it together with Linkerd and gain benefits from both tools. But as already mentioned, you should be careful with installing Cilium on existing clusters, as it does basically require changing your container networking stack. So, which service mesh is the best? There is no clear winner in all of the categories, but there are some obvious winners in each of the categories we explored. And keep in mind that it's impossible to compare every feature of every mesh, even if you look only at the 4 meshes that we took for comparison in this video. Still, let us provide our conclusions from this comparison. Consul Connect is probably the most mature simply because of Consul. Consul is a decade-old polished technology, battle-tested in huge production environments. It's a safe choice in terms of stability and features. There is only one problem with Consul Connect. It's not a purpose-built cloud-native service mesh, but rather a service mesh built on top of Consul. You have to run Consul agent in addition to the Envoy proxy. You have to maintain Consul cluster, and every Kubernetes resource specific to Consul Connect ends up being a Consul configuration object stored in Consul key value store, creating an additional level of indirection. Consul Connect also proved to be the hardest one to integrate with existing ingress controllers. Istio, popularity-wise, is the current leader in the service mesh space. Features-wise, it's the most powerful and advanced mesh. You can do many things with it, even if those things are tricky to configure. There's a big community around Istio, and you have native integrations with Google Kubernetes Engine and OpenShift. Installing and using Istio is complexity-wise like installing a Kubernetes cluster on top of a Kubernetes cluster. You get another few thousands of building blocks that you have to learn, but once you do it, you can achieve almost everything, except of course low latencies and resource consumption. Linkerd is the most performant and focused service mesh out there. It's intentionally small with carefully selected feature set, convenient dashboard, and a strong focus on doing just enough. Linkerd was the first service mesh, and the engineering team behind it learned a thing or two about how service mesh should look and work like. It's a pure joy to read the articles about how technical decisions were made for this mesh. Linkerd is also the easiest service mesh to get started with and integrate into existing clusters. But Linkerd can be used only with Kubernetes, so if you want to mesh together traditional infrastructure and Kubernetes, you're out of luck. And finally, Kuma is one of the newest service meshes, aimed at solving many of the mistakes other meshes did. It's very well thought, well documented, and feature-wise sits somewhere between Linkerd and Istio. Kuma claims to be a universal service mesh, meaning that it was built to accommodate both Kubernetes and traditional infrastructure into a single mesh, not unlike Istio or Consul. It also has an enterprise version with even more functionality on top. We were pleasantly surprised by both feature set of Kuma and how easy it is to use. Choosing a service mesh highly depends on your environment. Regardless of which mesh you choose, it's a big, complex technology that becomes an essential part of your stack. You should always start with the list of existing and potential future requirements and select the mesh based on those. Picking the tool only because it's the most powerful or because it has the best dashboard wouldn't be the right approach in the case of the service mesh. You might need to create a single mesh for multiple regions, data centers, clusters, and thousands of virtual machines, and then the only good choice might be Consul or Kuma. Or you might just need a mesh for your existing Kubernetes cluster to enhance but not overcomplicate your environment. And in this case, Linkerd is the best tool. If your company needs help selecting and integrating service mesh, please contact us at the email provided in the description below or via our website. We will schedule a call to discuss your needs and how we can help you with them. There are many more meshes that we did not explore, like traffic mesh and cloud-specific meshes, each of those with their own correct use cases. Please tell us in the comments which service mesh we should make more videos about and which important points you might have missed in this comparison. Don't forget to subscribe to our channel and press the like button. Thanks for watching!